Welcome to Penrose Learning, where we make understanding easy.
You start by identifying the function family. This matters because each type implies different domain rules. Once done, scan for vertical asymptotes or hole markers since those X values are excluded. Also check endpoints of segments on the graph. Open circles mean values are not included. Make sure to mark continuous stretches where the graph is present. Those X intervals are in the domain. Together, these observations give your initial candidate domain before precise notation and verification. Now translate visual features into interval notation. When the graph exists across a stretch, record that as an interval. Include endpoints if filled dots are present. Once done, remove any X values corresponding to asymptotes or holes by breaking intervals into unions. If the curve extends indefinitely to the left or right, extend the interval to negative or positive infinity. Make sure to double-check where the graph has gaps, so your final set accurately matches the observed presence and absence. Finish by assembling the interval union that represents the domain. Write single continuous stretches or use for separated pieces. Then verify excluded X values one more time. Vertical asymptotes and holes must be left out. Open dots stay open. If you're uncertain at any X value, zoom in on the graph or plug that X into the function rule to confirm. One key troubleshooting tip. If the graph looks continuous but algebra suggests an exclusion, trust the algebra and inspect closely for a hidden hole.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.